In this video, we will show how to find the target displacement in pushover analysis using SeismoStruct. The target displacement in pushover analysis approximates the maximum level of deformation that is expected during the design earthquake. In this video we will present the steps that need to be followed in order to define the target displacement. The first step is to define the loads that will be applied in order to perform the pushover analysis. All loads are defined in the Applied Loads module. By clicking on the Add button, a new window opens. From the drop-down menu, we select the type of load we want to apply. In this case, we select incremental load. Next, in the list of nodes, we select the node where the load will be assigned. Here, we choose node N111. We then define the direction of the load by selecting the appropriate axis. In this case, we select the x-axis. After that, we choose the load type. Here, we select force and enter its numerical value in the corresponding field. Once everything is set, we click OK to apply the load. We follow the same procedure to define the loads at the rest of the nodes. Moving on to the Loading Phases tab, we click Add to create a new phase. In the window that appears, we select Response Control from the drop-down menu. In the Maximum Displacement field, we enter the maximum displacement that will be reached by the controlled node specified below during the pushover. A reasonable value would be 2% of the total building height, which in this case is 0.18. Then, we define the number of steps for the analysis, which controls how the load is applied incrementally. Finally, we select the node where the displacement will be monitored and specify the corresponding direction. After confirming all the parameters, we click OK to apply the settings. Moving to the Target Displacement tab, we first enable the option Calculate Target Displacement. This will automatically run an eigenvalue analysis before the pushover analysis. From the drop-down menu, we select the design code that will be used. Next, we define the control node, which is the node where the displacement will be monitored. In this example, we select node N321. We also define the control direction, depending on the loading direction of the analysis. Control node and control direction are automatically assigned if the building modeler or the wizard facilities are used. We then move to the Limit States section, where we define the limit states for which the target displacement will be calculated. Finally, we proceed to the Seismic Action tab, where all elastic response spectrum parameters are defined. Having completed the pre-processing phase, we are then ready to run the analysis. We click the Processor tab. A new window opens, and we select the Run button. Once the analysis is completed, we can proceed to the Results section. We click the Post-Processor button. We select the Target Displacement module. In this tab, the value of the target displacement for all the selected limit states is presented, together with the capacity curve and parameters for the bilinearization of capacity curve, which is necessary in the calculations.